Okay, I know you're starting to get a taste of this. This is your third network application, and I know you're curious about seeing and testing the code, so let's dive right into it. This application simulates DHCP transactions and actually makes a DHCP server in the network, assign leases to clients that do not really exist. Now, I know you might think if we can make a server assign IP addresses to inexistent clients, could we use the application for network attacks like DHCP discover flooding or even create rogue DHCP servers? Well, the truth is we can do this. I actually have an extension for this application that I used in a testing environment, but I decided not to make it a part of this course for now. Our program will also simulate DHCP releases. It will either release all the IP addresses it received from the server or a single address that the user specifies. For the DHCP client simulator mode, assuming that there is an active DHCP server in the network, the user can choose to simulate any number of DHCP clients. All DHCP leases obtained from the server are saved in the DHCP leases.txt file, which is automatically generated by the program. After releasing all the addresses, the DHCP leases file is also cleared. Now you may ask yourselves, how do I create the DHCP packets necessary for a complete DHCP transaction? Meaning the discover and request packets, which are client specific. Well, the answer is always the Scapy utility whenever you want to capture, decode, analyze, or create network packets using Python. We've discussed about Scapy in the Python Networking with Scapy lecture, but now let's better see this application in action. I have the virtual machine connected to router R1 in our GNS3 topology. This router already runs the DHCP server and already has a pool configured. You can see the pool right here, or in the show output right here. I have also enabled DHCP events and packet debugging on R1, so you can see the packets that are sent and received by the router. Now let's run the application in the virtual machine. So Python dhcpsim.py. The first thing we should enter is the interface to GNS3. I will explain why when we'll study the code. So eth1. Next we get an user menu asking us what to use this program for. If you press S, then you get a message saying that the leases we get from the server will be saved in a text file, and then we are asked how many DHCP clients we want to simulate. Let's ask for just a single IP address, so 1. The interface on which to send the packets is the same, eth1. Now let's wait a bit and let's check R1. Okay, we can see a lot of DHCP debug messages in the CLI, of which the most important are the DHCP discover we sent. This is the one over here. Then the offer the server sent back to us. Then the request we sent. And finally the acknowledgement packet right here from the server that actually closes the DHCP transaction. Now, without quitting the program, let's open another terminal and check the DHCP leases file which was generated. So cat dhcp leases.txt. We see that the program saved the IP address it received from the server to this file, along with the IP address of the server and the MAC address of the client. Let's check if this is the same lease as the one registered in the DHCP binding table of the router. So let's do a show IP DHCP bindings. Okay, comparing the two, you can see that it is indeed the same IP address in the binding table and into our file. Great. Now let's get back to the first terminal and release the IP address we just got. So R for release. In this submenu, you can choose to release a single address or all the IP addresses we got from the server, in case you have simulated multiple DHCP clients. In our case, having just one IP address, let's choose S. Now the program asks us which IP address to release. Well, let's see the address. It's .2.1. Okay, so let me type it in. Okay, now let's check the router CLI. You can see the DHCP release packet being received on the router. Now let's check the binding table again. Okay, so the binding table is now empty, so the release procedure worked great. Okay, Finally, if you choose to release all the IP addresses received from the server, the program will also clear the DHCP leases file, in case you have multiple leases in that file. Again, as with the previous applications, you will have the entire code available for download in a future lecture. I hope this sounds interesting, and I assume you would like to see the code now.